coba record ya. Ini saya akan share screen. Oke, share screen. Oke, ini benar nggak sudah di record? Oke, terima kasih teman-teman yang sudah hadir di sini. Saya akan switch ke bahasa Inggris ya. Good morning everyone. Assalamualaikum warahmatullahi wabarakatuh. Thank you for your attendance. Kedengaran jelas nggak suara saya?
Jelas, jelas.
Jelas ya? Oke. Today we will try to continue about the what we call is as a positive series test. Okay, before we go further from the step 3 until 4 to 6. Okay, is there any question regarding this what we call it as a positive series test? And then one is the integral test, and then second one is a series test, and then third one is the ordinary comparison test. Is there any difficulty? I just uploaded in the two previous video of our lecture. We will you can try to look at it. I will put in the LMS, but it is not yet now. I just finished it to upload it. Okay, I will notify you whenever the video is ready to be shown in the LMS. Okay. Any questions regarding this one, especially for method 1 until 3? Ada pertanyaan nggak dari sini kira-kira? Jelas ya? Okay, no questions. So we will try to discuss now. We will try to discuss number 4 until 6. Okay, what we call it as a limit comparison test, ratio test, and then root test. Okay, to make this easier, I will put into a new. Okay, so this one. So we proceed to the third one, which is actually what we call it as no, the fourth one. Okay, limit comparison test. Okay, I will try to print screen it from my ebooks. Okay, so this is the third one. Okay, what we call it as this is number 3. This is method 3. Okay, limit comparison test. Okay, so what do we have here? Ini you can see my notebook, right? Bisa dilihat ya, ini saya, layar saya. Okay. What do we have here? This is what we call it as a limit comparison test. Okay. Suppose an are positive, and then bn is also positive series. Okay. And then what we are trying to do is to compare the limits or the ratio itself. Okay. The ratio of the an and bn, and then we calculate the limits whenever, and then let's say if the limit exists, and then it is L. Okay, and then L is actually positive and finite. Okay, ini artinya dia menuju suatu angka, dia lebih dari 0, bukan 0 ya, lebih dari 0 dan kurang dari tak hingga, artinya dia finite atau berhingga. Okay, so this is L is some value non-negative. Okay, positive value. Okay, and then the series an and the series bn konvergen. Kalau AN-nya konvergen, BN juga konvergen. Oke. Or jika AN-nya divergen, BN juga ikutan divergen or divergent together. Okay, that's the statement. Simply that is the statement. Okay, AN and BN are both, okay, dua-duanya bisa sama-sama konvergen, bisa sama-sama divergen. But now, if the L is actually 0, okay, jika dia 0, series BN converge. If the series BN converge, then the AN converge. Okay, kita akan lihat ininya apa? Example. We will try to look at the example. Okay, or let's say I will try to make it more simpler. So this is there are 2 points that I would like to emphasize from this one, this theorem. Okay, the first one, if L is actually is positive value but non-zero, okay, then this sigma, this is this AN and BN, okay, are both okay, both convergence or divergence, dua-duanya, okay, divergence. That's it. And then the second one, if L turns out to be 0, and okay, this is the conditions, okay, and then n, the sigma Bn converge, convergence, then the series An is convergence. That's the conditions. Okay, we will try to look at some example. Okay, of course we will try to look at some example. Example number one. Okay, I will little bit okay, this is the series 2n plus 3 divided by n to the power of 3 minus 5n to the power of 2 plus 7. Okay, and then n from 1 to infinity. Okay, question is check whether this one is actually converge or not. Okay, that's the idea. Okay, we will use limit comparison test to test this. Okay, we will use this one. Okay, for example, if you see it actually, kita lihat ya, di sini pangkatnya berapa? 1. Di sini pangkatnya 3. Okay, if we consider this question is actually, if we consider that this one is actually AN, kira-kira BN-nya seperti apa? And then the BN, to compare it. Jika kita ingin mengcompare. Jika ini adalah AN, and then BN is something that is more simpler, that we know in advance it is converged or not. Kalau kita ingin membandingkan dua buah deret, oke, dengan membandingkan, apa yang kita tahu? Deret P ya. Kita akan melihat deret P. Ingat P series gimana? A to the power of P. Kalau P-nya lebih dari 1, berarti apa? Konvergen atau tidak? If P lebih dari 1, then converge ya. Konvergen ya. Tetapi kalau dia sama dengan 1, Tidak ya. Oke. Untuk jika misalkan, for example, AN is actually this question number 1. What is the BN that we will try to compare? The clue is choose simpler form. Okay. Kita pilih pembandingnya itu baris yang lebih simple dari ini. Kira-kira apa untuk BN? Ada yang tahu? Ingat ini pangkat 1, ini pangkat 3. Berarti kita bandingin saja dengan choose. Ada yang itu enggak? Ada ide? Ini pangkat 1 di atasnya, di bawahnya pangkat 3. Berarti kita pilih 1 over n. Apa? Gini ya.
1 over.
Yang paling simple adalah n divided by n to the power of 3. Ini kan bentuk simpler dari ini ya. Tetapi ini kita sederhanakan menjadi 1 over n to the power of 2. Oke. Nah, ini kita tahu nggak konvergen atau tidak nih? This one is it converge or not? Converge? Konvergen atau tidak nih? Convergence? Ingat deret P? Deret P yang kemarin? Oke, saya buka ya contekan kita. Oke, contekan kita ada di sini. Mudah-mudahan masih bisa dibuka. Okay, this one, P series, okay, number 2. We will try to refresh it now. This is number 1. This is theorem number 1. This is P series, okay? Nih, okay. Jika P lebih dari 1, maka convergen, okay? Deal this, and then we will just use these facts, okay? We go back to our problem. So what can we conclude? This one is convergence, okay? Use a P series, okay? So we will try to compare now. We will try to calculate the limits, okay? Calculate the limit comparison. Okay, and then we take, what is the theorem? AN divided by BN, and then n goes to infinity. Okay, we will try to calculate this one. Okay, AN-nya apa? Yang di atas. Okay, the limit. First I will write down the limits. This is 2n plus 3 divided by n to the power of 3 minus 5n square plus 7 divided by apa tadi BN-nya? 1 over n square. Okay? Benar ya? And then we will switch again. Ini jadinya limits. Ini yang paling bawah saya taruh ke atas, oke? Okay? Yang bawah, yang di ini, yang pembagi yang di atas ini saya taruh ke bawah, oke? Okay? And then this is n square. Oke, okay. N square-nya dari sini saya masukin ke atas ini, jadinya 2n plus 3, and then yang bawahnya sama. Ini n to the power of 3 minus 5n square plus 7, and then n goes to infinity. I will make it simpler. Limit n goes to infinity, 2n to the power of 3 plus 3n square divided by n to the power of 3, this is minus 5n square plus 7. Now you know it. Kira-kira limitnya berapa ini? I do not have to repeat it again, okay? We did discuss this on the previous meeting, also in the calculus 1. Jadi berapa? Dibagi dengan pangkat tertinggi ya. So that we have, what do we have?
2.
2, 2. Okay. So the limits of an divided by bn is actually 2. And this one is actually L. Okay. This we got this conclusions. So we can refer to the theorem if the, jadi kita memenuhi yang mana nih? Memenuhi yang mana? Nomor poin 1, poin 2. Poin 1. Okay? So we are here, okay? For example, this one. Because our L is actually 2. And it is between this one. Jadi artinya apa? Kalau BN-nya divergen, so what is divergen? Sorry. BN-nya apa tadi? Bukan divergen, tetapi convergen. The BN is actually convergence. What can we say about AN then? Jadi artinya AN-nya adalah convergen atau divergen. So AN is also the same. Is also the same with the BN, which is converge. Okay, so this is the conclusions. So sigma AN is also convergence. That's it. Okay. AN-nya apa? AN-nya tadi soalnya. Okay. Ada pertanyaan sampai di sini? So far understandable? Okay. Jelas ya? We will go to second example if you do not have
Yeah, I
any
have a
question.
question.
Yes?
The BN is from, we just take the n from 2 and n to the power of 3. Is it correct, sir? I'm a bit lost.
This one?
Yes, sir.
Iya, kita bandingkan dengan saya pakai bahasa Indonesia, kita bandingkan dengan deret yang simple yang kita tahu. Deret apa? Salah satunya adalah deret P. Deret P series, oke? Okay? Deret P. Artinya apa? Kalau nilai P-nya itu lebih dari 1, berarti dia konvergen. Kurang dari sama dengan 1, divergence. Oke? Okay? Dan ini kalau kita lihat dari pangkat yang tertingginya, yang di atas pembilangnya adalah n, di bawahnya n pangkat 3, sehingga kita sederhanakan jadi 1 per n kuadrat. That's it actually. And then that's the idea to compare the Bn, to choose the Bn. Kira-kira gitu? Jelas nggak, Dava?
Jelas, sir, jelas.
Okay. We go to the second example. Maybe it's some more clear for you. We go to the second example of this one. And then the second example is check the convergency of the following tests, okay? N plus 4, okay? From n from 1 to infinity, okay? Let's say this is actually a n, okay? Bn-nya seperti apa? We will use the limit comparison test, okay? So what are we all trying to calculate? The an, the limit of an and bn whenever n is infinity. Okay, L. Ini an-nya adalah yang ini, yang bn-nya apa? Kira-kira? Ingat, pilih yang simple saja. Okay, this is the an. So what can we choose for the bn? Apa kira-kira? Langsung dicoba. What can we choose for the bn?
Is it 1, sir? The top 1?
1 apa? 1 apa?
1
Bn?
over
1 over
n.
n. Oke, pangkat 1 ya, karena ini akar, di sini kuadrat. Jadi ini tuh sebenarnya pangkat 1, oke? Pangkat tertingginya, oke? We will use this one. Okay, facts. Is this one convergence or divergence? Ini deret P ya, sama persis dengan tadi. It is converge or not? Convergent atau divergence?
Divergent, sir.
Divergence, okay? So I will try. Okay, this one is divergence, okay? We know it. Now we calculate the AN divided by BN, okay? Now we will check a look the AN. AN-nya apa? 1 over square root of n square plus 4 divided by BN. BN itself is 1 over n, okay? What do we have? The limits, and then n goes to upper part, n divided by, then this one is goes to the lower part, okay? Square root of n square plus 4. N goes to infinity. How can we do it? Berapa jawabannya kalau langsung?
1, sir.
1. Ada yang nggak ngerti? Anybody of you who do not understand yet? Oke. Ada?
Excuse me, sir.
Yes.
I'm a bit lost, but how do we know the BN is 1 divided by n?
Nih, ini pangkat tertingginya berapa dari bilangan ini? Ini ada akar, di sini ada kodrat. Berapa kira-kira? Pangkat tertinggi dari ini berapa? Kita bandingkan dengan deret yang lebih sederhana. Deret pangkat yang paling sederhana, yang paling simpel adalah deret P. Oke. 1 over n to the power of P. Oke, yang nomor 2 minggu kemarin. Bukan minggu kemarin, hari Selasa kita bahas. Ini akan konvergen jika konvergen if P is larger than 1. Okay, and then this one is divergence if P is less than equal to 1. This is P-test series. Okay, this is a simpler one. And then to compare with this part, we can just directly see what is the P here. Yang paling simpel dari sini, 1 dibagi dengan akar n kodrat. Ini kan ada kodrat tetapi ada akarnya. Berarti pangkat P-nya adalah berapa? 1 ya. This one. 1. Karena kan ini kodrat, di sini ada akar. Jadi pangkat tertinggi dari atas dan bawah ini adalah 1. Oke? Paham nggak?
Okay, sir. Thank you.
Okay. I will proceed to this one. If in case you still do not understand yet, ini adalah kita bagi dengan pangkat tertinggi. We divided by using the highest power, both numerator and denominator. Okay. Pangkat tertinggi dari yang di atas dan di bawah berapa? N. Okay. Pangkat 1. Jadi N dikali dengan 1. Ini ya, sama ya. Kemudian yang ini, yang akar gimana? Ini adalah akar n kuadrat. Ini saya buka. Ini adalah 1 dibagi dengan 4 dibagi dengan n square. Okay? Exactly the same. And then I took out this one. And then this is n times 1. Exactly the same. Nah, ini n kuadrat diakarkan. Jadinya berapa? N kuadrat diakarkan. Jadinya n. Oke. Tinggallah menjadi akar 1/4 per n square. And then n goes to infinity. That's all. Okay. And then this one is vanish. And then we just simply take the limits. Limit 1 is actually 1 divided by square root of 1. This is exactly 1. And then because of the linearity of the limit operator, this one goes to n square and goes to infinity, which is 1 over 1 plus 0. Okay, then we have actually 1. Okay, if the L is 1, what do we have? Jika L adalah 1, berarti kita pakai yang mana? So we got this case also, okay? Because this one is L is 1. Meaning that if Bn is divergence, An should also divergence. Okay? Nah, sekarang Bn kita apa? Divergen apa konvergen? Ini adalah divergence. Okay. Our Bn is actually divergence. As we have here. Okay? This is the divergence. What can we conclude with An? Jadi kesimpulannya An adalah the An is also divergence. Okay, because why? Because Bn, which is actually this one, is divergence. Okay, jelas gak nih? Are we clear here? Jelas gak? Ada pertanyaan? Any question regarding this
Sir,
one?
you know, to know the AN is divergent is from the term on the top. Is it correct, sir? Yang di atas itu, yang tadi di atas.
Coba pakai bahasa Indonesia.
Buat nentuin kalau mau tahu itu AN itu divergent atau convergent tuh yang pertama tuh ini ya harus tahu dulu yang BN-nya, ntar dicek ke yang atas itu.
Pertama, cek BN-nya konvergen atau tidak. Yang kedua adalah cek limitnya. Limitnya itu antara lebih dari 0 atau kurang dari tak hingga, artinya ada nilainya, atau dan kemudian lihat EN-nya. Jadi yang pertama kita cek adalah BN-nya, oke dia divergen, kemudian kita hitung L-nya, oke dia 1, artinya dia memenuhi kriteria nomor 1 di atas ini. Kriteria nomor 1 adalah L-nya yang kita hitung tadi 1, berarti dia memenuhi kriteria ini, maka AN dan BN itu tandanya sama. Artinya sama-sama konvergen atau sama-sama divergen. Karena BN kita divergen, berarti AN-nya also divergent. Okay, that's it. Jika L-nya sama dengan 0, dia butuh syarat tambahan. L sama dengan 0 dan BN sama dengan konvergen, maka AN disimbolkan konvergen. Okay, that's it. Ngerti? Dapat? Any questions?
Alhamdulillah ngerti.
Okay.
Sekarang lebih jelas.
Okay. Now we go to the number 4, method number 4. Okay. What we call it as a ratio test. Okay, I will enlarge this formula. This is from books. Okay. This is what we call it as a ratio test. This is number 5. This is number 5. What we call it as a ratio test. Atau dalam bahasa Indonesianya ini adalah uji hasil bagi. Hasil bagi. Oke, ratio test bahasa bahasa Inggrisnya. Oke. Now we will try to understand this theorem. Let AN be a series of positive. It is always okay. This is the first assumption. This is a positive series. Okay. And then suppose we'll enlarge this a little bit more to make it more clearer. Gimana ya digedein? Okay, my internet is unstable. Okay, kelihatan lah ya, tapi nggak bisa digedein lagi. Okay, anyway, this is what we define the limits. We define the limits here. Okay, limit. Jadi we take the limit AN plus 1. AN plus 1 divided by AN. And then we take the limits. Limit N goes to infinity. Artinya apa? Suku selanjutnya dibandingkan suku yang sekarang, okay, sama dengan row. Okay, we symbolized is as the limit value is row. If the row is actually less than 1, okay, case number one, row is less than 1. Okay, this is case number 1. And the series is converged. Artinya apa? Dia semakin kecil. Ini kan perbandingan suku selanjutnya dibandingkan suku sekarang itu sama dengan row. Row-nya itu kalau dia lebih kecil dari 1, artinya apa? Ini suku-sukunya makin mengecil. Maka deretnya konvergen. Oke, kasus kedua. Jika row lebih dari 1, artinya apa? Suku ini nambah terus. Lebih dari 1 kan artinya yang suku berikutnya itu lebih besar dari suku yang sekarang kan? Benar ya? Atau limitnya ini tak hingga, maka kita bisa simpulkan divergen. Nah, artinya apa? Suku yang selanjutnya itu selalu lebih besar ya. Lebih besar dari suku yang sekarang gitu. AN. Oke? Condition number 3, kalau row-nya, if the row itself is actually 1, the test is inconclusive. Artinya tidak bisa disimpulkan apa-apa. Itu mau divergen atau konvergen tidak bisa. Oke? Now we will go to some example. Oke? Kita akan coba memahami ini dari pertanyaan. Oke, example. Example number 1. Okay, let's say check the convergency. Check the convergency of the following series. Okay, this is the series. 3 to the power of n divided by n factorial. And then n goes to from 1 to infinity. Oke. Oke, dipahami? Kita akan menggunakan rasio tes. Oke, kita akan menggunakan rasio tes. Caranya gimana? Ini adalah apa? This one is actually an. Okay, we will check the row itself. Okay, we will check the row. Limit of an plus 1 divided by an, and then n goes to infinity. Okay, Fadli Ramadan sudah hadir. Okay, jelas ya? So this one is this part. So what do we have? An plus 1. Jadi kalau an plus 1 gimana? Limit, and then n goes to infinity. Kita akan substitute dengan ini ya. Yang atas adalah suku an plus 1. Okay? 3n plus 1 divided by n plus 1 factorial. Okay? This is actually an plus 1. Jelas ya? And then the an itself as in the right hand side. 3n divided by n factorial. Okay, we will calculate this. We will try to simplify this form. It goes to infinity. Ingat, ini adalah saya akan sederhanakan supaya lebih simple. Tapi kalau Anda sudah ngerti bisa lebih cepat. Ini yang atas 3 dibagi dengan 3 ya. Gini ya, 3 pangkat n. Jelas ya? Nih. Nah, ini dikali faktorial yang di bawah ini tentu saja menjadi ke bawah. N plus 1 factorial. And then this one, the lower part is become in the upper part. Gitu ya. Jelas ya? And then now, 3 pangkat n plus 1 dibagi dengan 3n. Jadinya adalah, what do we have here? 3 pangkat n plus 1 dibagi dengan 3 adalah?
3 pangkat 1.
3 pangkat 1 atau 3. Oke. Nah, faktorial gimana? Faktorial. Intermezzo. Do you still remember what is actually factorial? Di Matdis ada nggak nih? Banyak kayaknya di Matdis ya. Faktorial. 3 faktorial dibagi dengan 4 faktorial. Atau ini sama dengan 3 faktorial dibagi dengan ini ya. 3 faktorial dibagi dengan 3 plus 1 faktorial. Atau seperti ini. Oke. Jadinya apa sih sebenarnya? 3 dikali 2 kali 1 kan. Sini adalah 4, 3, 2, 1. Sehingga coret. Sehingga what do we have? 1 per 4. Itu ya intermezzonya. Oke, what do we have here? N divided by n plus 1 factorial. What do we have? Dari sini bisa disimpulkan apa?
1 over n plus 1.
1 over n plus 1. Yes. 1 over n plus 1. That's it. Hasilnya adalah, so what do we have here? Kalau n-nya menuju tahingga berarti what do we have? Limits. Limit berapa nih? Limit lagi.
Is it zero, sir?
Berapa?
Zero, sir.
0. Oke. Benar ya? Jangan bingung. So, what do we have for a row? This is our row, okay? This is actually the row. Kalau row-nya 0, berapa berarti? Kurang dari 0 atau enggak? Kurang dari 1 atau tidak? Nih, kita switch ke sini. What can we conclude? Kurang dari 1, okay? So, this one is actually less than 1. What do we, so the series of AN konvergen atau tidak?
Convergent.
Convergence. Oke, that's it. Jelas ya? Kita udah berapa contoh nih? Baru 1 ya. Oke, 1 contoh lagi. So far, understandable or not? Sudah dimengerti atau tidak? Understandable? Yes, I hope so. Okay. Okay, another example, okay? Another example for this case. This is example 2. This is example 2. What do we have here? Check the convergency of the series using the ratio test. Okay. For example, this one is 3 to the power of n divided by n square. Okay, n goes to from 1 to infinity. Okay. Okay, di sini dulu. What do we have here? This is our AN. Okay, jelas ya? Now we will try to calculate the limits of AN plus 1 divided by AN. And then n goes to infinity. Okay. Nah, sekarang kita definisikan AN plus 1 jadinya apa? N goes to infinity. Okay. AN plus 1 is 3 n plus 1. Okay. Divided by yang ini ya, suku yang atasnya. N plus 1. Plus 1 square. Divided by 3n. Divided by ini ya, n square. Jadinya berapa nih? Oke. This one I will try to simplify. N plus 1 divided by 3n. Okay, this one. Okay, this one become in the lower part. N plus 1 square divided by n square. Okay, n goes to infinity. What do we have here? Jadi berapa nih? Ini kita coret. Jadinya berapa? Limit 3 ya. 3. Okay, how about this one? N square plus Ini saya breakdown supaya simple ya. N square plus 1. Saya breakdown jadinya 2n plus 1. Benar nggak? Masih benar ya? So, ada yang bisa nebak? Berapakah limitnya kira-kira? Guess it.
3, sir.
Berapa? 3.
3.
Benar. Oke. Benar ya, Sinta? Ada yang belum ngerti kira-kira? How can we calculate this one? Becomes 3. Sama, berulang-ulang. Oke, tekniknya masih sama. Jika n menuju tak hingga, kita ambil untuk bilangan berpangkat ya, polinomial, kita ambil pangkatnya yang tertinggi. Oke, I will try to break down. I hopefully you will all understand it. Ini saya akan breakdown supaya untuk bagi yang belum mengerti. Oke, limits. Nah, n yang paling tinggi adalah n kuadrat. Oke, dan ini dikalikan dengan 1 untuk yang penyebut pembilang. Ini adalah juga sama. 1 dibagi 2 per n ditambah dengan 1 per n square. Okay, and then n goes to infinity. And then this one is also the same. This is vanish, and then what do we have? We have 3, and then this one is 1 plus 0 plus 0. Okay, and then we got 3. So the row itself is actually 3. Benar nggak? Row ini ya? Row. Row-nya 3. Artinya berapa? Lebih dari 1 ya. 3 artinya lebih dari 1. Yang ini ya. Second one. The second conditions, okay? Row is actually larger than 1. What does it mean? So, what can we conclude then? So, the AN is divergence. Okay. Okay. So far, understandable? Ada pertanyaan nggak kira-kira? We will go to one method again before we reach 11 p.m. Satu metode lagi ya. I hope you understand the first two method. Now we go to the last one. What we call it as a root test. Okay, root test. Unfortunately, it is not here in the books. Okay, I will try to write it down. Okay, what does it say? Itu ngomong apa sih sebenarnya? Consider. I will write everything here in English. Okay, if you would like to know the Indonesian version, please refer to the PowerPoint that I have sent in our group. Okay. So this one is actually what we call it as a root test. Okay, consider the series AN. Okay, n from 1 to infinity is actually positive series. Okay, it is as usual. This is the first example. N jika n consider an this one, and let's say a is actually the limit itself, the limits of an, okay, square root of n to the power of n, and then the limit n goes to infinity. Ini adalah let's say this one is actually, we assume it, okay, the an. Point number 1, okay, if a is less than 1, then okay, then the series an convergence, and then the second one, if a is actually larger than 1, then the series an divergence. Divergence. Ada T atau enggak ya? Ada divergence. Ada T ya, convergence. Okay, number 3, if A is actually 1, then no conclusions. Oke, jelas ya? Ini seperti apa sih sebenarnya AN ini? We will check by example as usual. Okay, example 1. I use this one. Example number 1. Test the convergency of the following form. Okay, n is 1 to infinity as usual, 2n plus 2 divided by n minus 1, and this one is to the power of n. Kebayang nggak nih? Konvergen atau tidak? Ada pangkat n-nya naik, membesar terus ya ini. Coba tebak di awal, ini konvergen atau tidak kira-kira? Ini pangkatnya naik terus ya, benar nggak? Ada pangkat n. Dugaan saya ini divergen gitu, karena ini membesar ya, sangat membesar. Okay, we will check using ratio test. Okay, we will test using this one. How can we do it? We define the A first. Okay, define A. This one. A is the limits of the AN. AN-nya mana? AN-nya yang mana nih? Oke, AN adalah semuanya ini ya. Ini adalah AN. Oke, we check the limit of that. But kita di akarnya kita akarin lagi pangkat n. Jadi artinya apa? We check the roots to the power of n of the AN itself. Then n goes to infinity, and then limits to the n goes to infinity, and then this is an. We write it down here, 2 divided by n minus 1 to the power of n. Akibatnya apa? Dia pangkat n, kemudian diakarkan pangkat n. So what do we have? We have only this following term. Okay, the power itself is vanishes. I mean, okay, 2n plus 2 divided by n minus 1. Benar nggak? Oke, langsung. Berapakah ini A? Oke, berapakah A? Are you still there? Langsung.
2, sir.
2. Oke, benar ya, Sinta? 2. So A is actually 2. This is the conclusion. What can we conclude from this one? Kalau dia berdua berarti, so if 2, then AN is actually larger than 1. What can we conclude from this one? So limit A, divergence. Okay, that's it. Okay, paham nggak? So far, understandable? Okay, kita lakukan lagi contoh. Okay, another example, exactly the same, but using the ratio test, we will use another example. Example number 2. Okay, this is the sigma. This is n plus 2 divided by 2n minus 1 to the power of n. Okay, and then n goes from 1 to infinity. Okay, we will try to check also this one. Okay, coba diduga ini konvergen atau tidak. Ini pangkatnya membesar loh. Pangkatnya membesar, pangkat 1, pangkat 2, pangkat 3, kebayang ya? Nah, tapi dipengaruhi oleh di dalaman ini. A-nya ini. Okay. Can you guess in advance whether this one is convergent atau tidak kira-kira? Ini pangkatnya naik terus loh. This is A N. Okay. Anyway, we will check. Okay. A we define as okay. We define as square root to the power of n the an. Okay. This is an. I will write it down again to make sure you remember it. Okay. And then n plus 2 divided by 2n minus 1, and then this one is to the power of n. Sorry, n. Okay, and then it's become the root and the power itself vanishes. Okay, limit of n plus 2 divided by 2n minus 1, n goes to infinity. Oke, langsung berapa nih?
Half, and it's become convergent.
Half. Oke. Setengah itu berapa? Kurang dari 1. Oke. So A, I will try to write it down. A is less than 1. What can we conclude? So
Convergent.
the limit and convergence. Salah. Okay. Okay. We finish. Okay. I will try to recap everything that we have. Okay. Within this week. Okay. This one. I hope. Hopefully we completed here. Okay. Okay. Previous in the last Tuesday we have this one. We have discussed this part. Okay. And then now we completed this test. Okay. Any question regarding this one? The material for this week is finished actually, but we can also continue with some conclusions. I will try to continue with some conclusions. Okay. Sebentar. Okay, I will stop sharing first. Oke, sebentar ya. Saya akan recap. Kita sudah ngapain aja sebenarnya. Oke. I will try to recap what we have actually discussed. So what do we have? Positive test series. Yeah, this one. Okay, this one. Okay, I will try to recap what we have discussed so far. This is the first one that we have discussed. So integral tests. Okay, the following are the exam example. Number 1, number 2. We have discussed this on the whiteboard. And then this one is actually a P-series test. Okay, we use this extensively, so please remember it. And then this one we discussed it last Tuesday. Okay, this one is actually ordinary test comparison. And then those are some example that we have already discussed. And then the fourth one that we discussed today is actually ratio test, limit of ratio test. Okay, and then this one is number 5. This is a ratio, what we call as a ratio test. Okay, this is just some example. And then the last one is number 6, is actually root test. Okay, the complete storyline is actually here. But if you know, if you would like to know the detail itself in this, and then it is recorded in this video. Okay, so what can we conclude now? This is some example. We discussed it already here. So this one, let me try to conclude it. Okay. So to test, I will use some laser pointer to discuss the convergency of this series. Okay, we can take a look the element itself. Okay, an. Okay, the first conclusion: if the limit an is not zero, okay, it's not zero, then the an is divergent or not convergence. Okay, this is some conclusion. The first step that you should check if you are given a question, okay, the first step by step that you should check is from 1 to 4 as listed here. Okay, the first one, check whether the limit is not zero. Okay, tapi kalau misalkan limitnya 0, kita bisa apa? Kita tidak bisa conclusion, we cannot conclude anything. Okay, we should do positive test series. Okay, number 2, if it is not zero, what can we do? If an, we check the question itself, an has some form n factorial, r to the power of n to the power of n, then we use this one. Okay, ratio test. Okay, and then number 3, if an is actually only to the power of n, that is actually constant, then we use the limits. Okay, the limit ratio. Okay, and then the last attempt is actually we use ordinary ratio test, and then root test, and then integral test. Okay, ini jadi integral test itu yang terakhir yang kita lakukan. Okay, that's all for today topic. Okay, please prepare it also for the next, because tomorrow we will do some tests for CLO1. Try to concentrate on this one. But today material, I will try to upload it and then put it on our LMS. Okay, the video, I will put it on our LMS, the video link. Okay, any questions regarding this one?
Sir, can I have the whiteboard?
The whiteboard, this one you mean?
Yes, I mean the file.
Oh, yang ini? Okay, I will I will try to send it. Ini atau videonya? The video.
Yang di whiteboard, sir, yang putih itu.
Oke, ya. Gimana caranya? Ini agak banyak soalnya. Saya ekspornya bagaimana ya? Nanti kita lihat ya. Ini udah dicoret-coret tapi nggak masalah. Maybe I can.
Gak masalah, sir.
Okay. I will try to do it later. Ini oke. Saya akan coba lakukan nanti ya.